So is this the type of innovation that could be quite groundbreaking for industry?
It's going to be a game changer, this one, the way we do breeding and also the way we might practice harvesting practices and real-time information to farmers and millers. So yeah, it's very exciting if this is turn out to be very successful, yes.
Hello, I'm Sonia Campbell, and thanks for tuning in to the latest edition of Cane Matters. Now, imagine you're a cane grower standing in your paddock and being able to use a drone to measure CCS levels in the stalks of your cane. It may sound a little like science fiction, but it's rapidly becoming science fact. Yes, this promising technology is here, and a new research project being undertaken by Sugar Research Australia's expert team of remote sensing specialists, led by Dr. Sujesh Natarajan, is aiming to turn this breakthrough science into real in-field application, including in SRA's variety breeding program. Hyperspectral imagery shines thousands of narrow bands of light to measure wavelengths within a plant and can be used to detect data such as plant health and nutrient levels. And in this new SRA project, it's hoped it can also predict sugarcane CCS in real time. An exciting part of this project will be the use of drones, which will be equipped with this hyperspectral technology in the hope that these two technologies combined can eventually be applied at farm level and across industry. Here to help explain this new project is remote sensing specialist Johan Deutschenbaur, who is part of the team working on the new trial work. Welcome, Johan.
Thank you, Sonia.
Thanks for joining me. Johan, tell us about this new exciting project.
We just recently had this project approved from SRA's 10-year anniversary fund, where we will be looking at hyperspectral imagery to predict sucrose buildup in sugarcane by screening the leaves in the trials. So we have a trial established in Banderberg where we already have known low and high and unknown CCS varieties. So we will be screening this trial, hopefully at least 4 times through a year, and then we will go down and ground truth the actual CCS levels in this genetics to see if we can find a peak in wavelengths that correlates to the high CCS levels.
As you said, you are using hyperspectral technology. It sounds pretty high tech. Can you explain what it actually is and how you're using it in this project?
Well, it's just a very expanded version of multispectral imagery, I guess. So multispectral normally only reads 5, 6, 7 different wavelengths, while hyperspectral imagery reads thousands of different wavelengths. So it's a lot more data to be able to work with. So it reads the reflectance of the sun from the leaves up, and the sensor picks up on this. So it's more of a sun reflectance and light that the sensor picks up that gives us data of the content of the leaves. So hyperspectral imaging can actually read the contents of leaves and folio components inside the leaf, which is what we are looking for, and see if we can find the sucrose buildup in the leaves based on the hyperspectral imagery. We will look and analyze that data for high CCS contents, which we obviously will be ground truthing as well in Banderberg, physically biomassing the trial. So we are trying to find if we can read the actual contents and characteristics of the leaf that correlates to the stalk sugar contents.
Have we used this hyperspectral imagery technology before in our research?
Yes, we have, yes. So we have been able to pin down nitrogen fixation in leaves using hyperspectral imagery before. Where we had a trial with different nitrogen fertilizer requirements. So we had low, medium, and high, and we can actually separate the treatment just by hyperspectral imagery based on nitrogen fixation in the leaves.
Do you know if other ag industries are utilising this technology as well?
Absolutely, yeah. In the US, they have done this also for a very long time, not so much with sugarcane, but all other crops like barley and cereal in general. So it's a proven technology. Which we have proven to ourselves that is actually a good way to look at plant breeding through phenotyping.
As mentioned earlier, this technology is going to be attached to drones in the project to collect the multispectral data sets. How close will you need to fly the drones to the cane? And at what type of speed will you be flying them to accurately collect readings?
Since this is new sensor and everything, we'll have to optimize the parameters for the actual data collection. But currently with multispectral, you can fly anywhere between 40 and 60 meters and still get very good results. It will take roughly about 20 minutes and you can cover maybe 10 hectares of fields, which is fairly large trials.
Wow, that's a pretty amazing balance of speed and precision. It's impressive that you can get that sort of accuracy in such a rapid aerial assessment. Currently, in our breeding program, SRA uses near-infrared technology, or NIR, in our juice labs to assess CCS content from cane grown in our variety trials. NIR is the tech that is stealing everyone's attention of late. There is a lot of interest in it, and for good reason. We use it in our breeding program to also detect other important measurables, such as fibre content, pole, bricks, and purity. We also extract the juice from cane samples in our juice labs to validate the NIR calculations. This is a highly effective method. However, this aerial assessment you are trialling with the drones and hyperspectral technology is potentially, it seems, less labour-intensive and remarkably faster?
Yes. So currently we have to obviously have laborers out in the field actually doing the sampling, which is sometimes fairly large fields and a lot of genetics that we have to test. And then they have to obviously strip all the cane just down to the stalk, and then we have to mulch that up, run it through a NIR machine to decide the fiber quality, and then we also have to press and check CCS levels in the cane as well. So it's very time-consuming, and it's destructive sampling as well, which could be bypassed, I guess, with this type of technology. As we know, field work around the North Queensland or in general in Australia is normally working in hot and humid conditions. So not only will it be financially more reliable, but also a safer way to collect data. Flying the drone, we can also collect all the data within 20 minutes of a flight, where there could be several days or even weeks to actually manually test things in fields, like CCS, for example. So if we can in some way bypass that manual labor with hyperspectral imagery, we will be able to fast-track the genetic selection through the different stages of the breeding program.
That was my next question. A big prize in this method, if it can replace existing testing methods, is there potential for accelerated genetic gains in sucrose yield through our breeding program?
Absolutely, because if we can discard the low CCS varieties, we can focus more on the higher ones. And if we can put more high-yielding CCS varieties on our trials, it will automatically make the breeding program more efficient.
How promising is this approach when it comes to advancing our breeding strategies?
I myself is very excited about this one. It's not only about SRA's plant breeding program, but it can also give the farmers and growers a real-time sugar content. So we can optimize dry-up periods before harvest so that we can actually harvest the crop at the peak of its sugar contents, which will obviously be beneficial for growers and millers and also for SRA.
Now, we currently have trials running across multiple growing regions and in multiple demonstration sites using handheld NIR units to predict CCS in the field. But again, this is quite labour intensive. Now, integrating drones into our testing methods, as well as this hyperspectral imaging, potentially improving both efficiency and scalability, you can understand why growers and millers would be quite excited about this project.
Yes, we are. We are excited about it. Normally, growers and millers never really know the sugar contents at harvest. This will require obviously laboratory testing. Most of the cases, they only find it out from after harvest, from the mill reports that they do have. But if we can pinpoint the sugar contents peak before harvest, we can optimize the harvest procedures and the sugar contents.
So it could potentially provide real-time data for on-the-go crop management.
Absolutely. Yes. So I guess again, if we can get a real-time sucrose level in the cane, we will be able to advise and more optimize the dry out periods for the farmers so that they actually do harvest at peak sucrose levels. So it goes up during the dry period, but it will also go down after a while. So we want to hit that right at the peak of the sucrose. So this will obviously require further investigations after this based on salt types and varieties you have. But yes, that is the aim of our project at the moment, yes.
So is this the type of innovation that could be quite groundbreaking for industry?
It's going to be a game changer, this one, the way we do breeding and also the way we might practice harvesting practices and real-time information to farmers and millers. So yeah, it's very exciting if this is turn out to be very successful, yes.
I suppose the burning question industry would ask is, what time frame are we looking at? When will you have enough data to validate the effectiveness of this technology?
We'll do this 4 times a year, or we will actually spend a week actually going into the field and testing the CCS, and then we compare that with the data that we get from hyperspectral imagery. And 3 years should give us enough time to indicate and give recommendations of if this is possible or not, which we all hope it will.
Well, it all sounds very exciting and promising, and I would imagine technology that could be applied to other areas of our research and the industry.
Yeah, absolutely. It's a very rapidly growing industry when it comes to phenotyping in general, multispectral, hyperspectral, and I think it will only get more accurate as we go along. So there is no real end to what it is that you can look for. You can look for water contents, moisture, all sorts of these things already. So what might come in the future, I'm not sure, but it's a promising methodology.
Well, as I said, this technology sounds both promising and exciting, and it's clear it holds a lot of potential. Hopefully we'll be able to report some positive outcomes in the not too distant future. Thank you so much for providing your insights today, Johan. It's certainly been a fascinating conversation. To our listeners, thanks again for joining us. If you'd like to learn more about this project or other innovative trials currently being run by SRA, jump onto our website at sugarresearch.com.au and search for our research projects page. Thanks again for joining us for another edition of Cane Matters.